Kia ora and welcome to question 3 of the 2012 School Calc exam. This is going to be one of my favourite questions in Scholarship Calc, just because the answer to part B is so sweet. But let's get through A first up. There is a hence here, it doesn't say hence or otherwise, saying that you need to use the first answer to prove the second. Actually, the result from the first makes the second one very simple, but we will look at it in a different way as well. Okay, so first up, we're differentiating x cosine x. d dx of x cosine x is asking us to differentiate that. That's what the notation means. So we use the product rule. Diff the x multiplied by the second term, diff the cosine multiplied by the first term, and that's equal to cos x minus x sine x. And it then asks us to use the result to find the integral. That's another kind of hence statement, use this result. So if we've just diffed x cosine and the result is cos x minus x sine x, then if we anti-diff both sides, anti-differentiating both sides would lead to x cosine x equals to the antiderivative or integral there of that. Hopefully that makes sense, that the derivative of x cosine is equal to cos minus x sine. The antiderivative of cos minus x sine must equal to x cosine. That was a bit of a mouthful. Okay, but the thing is, on the right hand side we've got an integral of a difference, which can be written as the difference of two integrals. It's a linear property of integrals. And this is the integral that the question wants us to find. So we can move that to the left-hand side of the equation to make it a positive, and move the x cosine to the right-hand side of the equation. And then we just have to anti-diff cosine. Okay, the antiderivative of cosine is sine of x. We need a plus c somewhere. Let's put it at the end. Okay, and that is the answer. Basically what they've done is stepped us around integration by parts. If you know integration by parts, you know that finding an integral like this one, which is a product of two things, we can make x equal to f and sine of x equals to g dash. If you haven't seen integration by parts before, probably best to look up other videos to explain it, but it is reverse product rule. And then we get f dash from that is equal to 1, and g, the antiderivative of sine x, is negative cosine x. We don't need a plus c. The integration by parts formula tells us that it's fg minus the integral of g dash f, no, f dash g. And fg in this case is sine x, 1 times sine x, and the integral of f dash g is integral of negative cosine. The integral of negative cosine is negative sine, but there's also a minus there, so we get sine of x plus what has happened. Something has gone awry. Oh, because f wasn't equal to 1, f was equal to x, so there needs to be an x there. That's better. I was going to end up with sine x. I've stuffed this up completely. My goodness. F times g. I was going to end up with sine x plus sine x, which is clearly not the answer. F times g is minus x cos x. And then we're anti-diffing cosine, which is sine. Minus x cosine x plus sine x plus c. Hallelujah, we got the same thing. There are other ways to do integration by parts successfully, but we didn't need it for this question because we had a result, the derivative of something which was related, so we could just work it backwards. Okay, the second part of the question asks us to integrate the same thing, but just between 0 and n pi for positive integer values of n. Zero to n pi x sine x. Well, that's just going to be evaluating this dude between n pi and 0. For any value of n, sine of n pi is going to be 0. Okay, sine of 0, sine of pi, sine of 2 pi, it's always 0. Cosine of n pi alternates. So when we sub in n pi into the expression, we get 0 minus n pi times cosine of n pi. Then we sub in 0, sine of 0 is 0, and the other term is also 0. So we end up getting minus n pi times cosine of n pi. Let's think about what the cosine graph looks like. When n is even, so 2 pi, 4 pi, etc., that's when the cosine is maximised at 1. So if n is even, cosine of n pi is 1, so the integral, or let's call this I equals negative n pi. If n is odd, it's the opposite, because cosine of pi or cosine of 3 pi, etc. is equal to negative 1, so I will equal to n pi. I've written that as a piecewise thing here, but you could also write it that I is equal to negative 1 to the power of n plus 1 multiplied by n pi. That negative 1 to the power thing's like an on-off function. It alternates between minus 1 and 1 depending on if n is even or odd. Okay, part B, my favourite question. Consider the points in this region, shown in the Argand diagram. Consider all points in a right-angled sector of radius 1, except for the point z equals 0.8 cis pi over 6, which seems like a pretty strange choice of z. Sketch the region containing all points w cubed, where w is a point within the region R. So what you should know for this problem is that if you have, no, we don't want to start with w. If you have a complex number z, which is in polar form, r cis theta, then when you cube it, you get r cubed cis 3 theta. So your modulus cubes and your argument multiplies it by 3. Okay, and that's what we're doing here. Sketch the region of points that are w cubed, where w is a point within the region. So in other words, w is actually, I could have started, sorry, with w there. W is some complex number. Let's say that value there. Then when we cube it, we're going to, the modulus is going to be cubed and the angle is going to be multiplied by 3, where theta is the anti-clockwise angle, and that there is r. Now, we're inside a sector of radius 1. So what does that mean in terms of the r value? R value is going to be less than, because it said in a right-angled sector. Does that mean the boundary? Probably not. So if we're within a distance of 1 from the origin, when we cube that value, we're going to get closer to the origin, because when you take a number that's less than 1 and you cube it, you get a smaller number. Okay, and in terms of the angle, if our w is chosen to be like right up on this boundary here, then the angle, when we take pi over 12 and we multiply it by 3, we get pi over 4. So that's going to be the lowest angle of the result. Or if we take w to be like on this bigger boundary here, which is pi over 12 plus 90 degrees, or pi over 2, we need to consider what happens when we cube that, because that's going to be the biggest angle of the result. So lowest theta is pi over 12. So I need to make that a bit clearer. No, lowest theta for W is pi over 12. Lowest theta for W cubed is 3 pi over 12 or pi over 4. Maximum value of theta for W is pi over 12 plus pi over 2, which is 7 pi over 12. Therefore the maximum value for W cubed is 21 pi over 12. And those both divide by 3 there, we get 7 pi over 4, which is less than 2 pi. So we don't have a problem where we have to go more than one revolution around. And then the modulus, r is less than 1, so r cubed is going to be less than r, which is less than 1. Okay, so what does our final result actually come to? Let's move this all down to here. How straight is my writing today? Oh, not too bad. Okay, so our region. If you've never seen the question before, then you're in for a little bit of a treat here. The lowest value of pi over 4 for the argument is 45 degrees. The largest value is 7 pi over 4, which is the same as negative pi over 4, so that there's a right angle. And the r value at maximum is going to be 1. That's if we take a w value, like I say, right on the boundary. If w is there, then its modulus is 1. When we cube it, its modulus will stay as 1. I'm not too sure whether we include the boundary in this because it didn't really specify. So we end up with a circle, the same size circle. Radius actually really should be, no, we'll hold the suspense a little bit longer if you haven't seen this. That's a terrible circle, but it's going to have a radius of 1. Should be flat down there. Cool, and then we've got that missing point, that point Z that wasn't allowed, 0.8 cis pi over 6. So we need to exclude that from our region that we're making. So remember that W didn't equal 0.8 cis pi over 6. The W cubed therefore can't equal 0.8 cubed cis 3 pi over 6. And 0.8 cubed, 8 cubed is 512, so it's 0.512. And 3 pi over 6 is equal to pi over 2, so cis pi over 2, that there is 0.512i. So we need to exclude, I'll put a little hole there, very small hole, and voila, Pac-Man. And I remember a student that did this exam. He actually did very well on this 2012 exam. I think he was second in New Zealand. Shout out to Bowen if you're watching. Unlikely to be. But I remember talking to him on the phone after the exam and him going through his questions and telling me whether he got things right or not. And he was very confident. And he got to question 3 and he said, I'm definitely sure that I'm correct with this problem, because the answer came out as Pac-Man. Now, I hadn't seen the paper at that point, so I had absolutely no idea what he was talking about. But yeah, very, very satisfying to see an answer that comes out like that. Catch you in the next one.